We would dance off to save the universe to begin every podcast now.
I don't know. I just was kind of in the mood. Happy tax day, or almost tax day. Not tax day because it's really a month later this year. I don't know.
I just decided to go with the old deadline. I did not want to learn which things were and were not adjusted. It was too much for me.
I was explaining to somebody this week why I was doing my taxes, because we work with someone to do our taxes. And I was like, well, the person we work with goes on vacation on April 16th every year. So my taxes are going to be done on the 15th. Anyways, hi.
Hi, Eric. How are you?
I'm actually pretty good. It's been a pretty decent week. How about you, Adam?
It's been good. A lot of people at work were out today getting their vaccine shot, which I found very encouraging.
Happy Vaccination Day in California.
Yeah, they opened up the eligibility in California pretty wide today, which is fantastic.
Nice. Yeah, I hear lots of people getting shots, so this is all good. Fingers crossed we're all going to have our shots, by, soon. It'll be nice. Shall we do some engineering in our rubber ducking ways tonight? Welcome to Rubber Duck Engineering. If you've never been here, we have no idea what we're doing, but we occasionally write some code of some form.
We try our best. We'll slam our head against the brick wall until the brick wall has a big head-shaped hole in it that we can crawl through.
Yeah, or our heads have a brick wall-shaped hole, but yes. So tonight, for no particularly good reason, we were going to go look through some code again that I've written, because for whatever reason, I really like writing games of any form in simulator capacity, and then using the simulators to understand what actually is going on in the games.
Yeah, so in the green room, Eric said something very intriguing to me, is that he was 3 or 4 cards away from completing this game. And I was like, oh, that sounds like a really fun time to dive in and see what's going on in this project. I don't even know what this game is, so this is going to be an adventure.
Well, last time we did a game that was popular with my kid. This time we're doing a game that's popular with my wife. And she and I were actually working on this together as part of learning Dart and Flutter, because she does other technical things and hadn't, done this part of the world. But I kind of got ahead because I got into it as I do. And
I don't know that feeling, Eric. I've never experienced that in a relationship with you before.
And then now I'm explaining it, and I used all the deepest, darkest corners of Dart.
Did you use the Elvis operator?
The Elvis operator?
Oh, the Elvis operator. Maybe this is old-fashioned.
I'm trying to remember what the Elvis operator is.
The Elvis operator is the question mark dot thing that says if the thing on the left, if the thing on the left is null, then the whole thing is null. Otherwise, go access some property of it and go deal with that. It's Elvis because it looks like it's hair or something. I didn't quite understand.
I think I wanted this today. I think I'd forgotten. I definitely used the question mark equals, assign if not null. And I definitely used modulo division. Anyways, where I was, the file where we started, and we'll get to the code here very shortly, I was using Dart const constructors and const asserts. And it was like, this is not where we really should start our Dart journey together. So,
welcome to the deep end.
Yes. Okay, before we get to the code machine, I will show you, I have a box here.
Yeah. What game is it that we're doing?
It's a game. It's a game. It's like a game where you go spelunking in a dungeon. There's a lot of random. And there's a lot of rules, way more than Colburn Quest. You go digging in this dungeon.
Whoa.
Thing. You have this token. You walk around, and the blue things are icy, so you have to stop when you hit one. And there's a dragon that gets mad. And, hold on, where is my finger? This is the dragon. It gets more mad.
What happens when it gets maximally mad?
So there are these, because the game is very physically based. I think just games are. There's these cubes that are used to track everything, and it's weird because and I designed it wrong on the system. We can go look at it, but there's 60, or you have 30 cubes, and your cubes can be in various places. But inside the program, like I can make more cubes. Like that's just copying copying an object, no problem. But I have to be really careful not to make more than 30 because there's a whole bunch of rules about like, well, if you're out of cubes, then you don't do this.
Uh-huh.
Anyways, I learned after I'd written it all, I realized that what I should have done is I just should have made 30 cubes and then made an enum about like where each cube was.
Mm-hmm.
And then it's very easy to like walk 30 things and collect, oh, here are the 3 that are in this place. But I didn't do it that way. Instead, I carefully track each cube and I have asserts to make sure that I never make more than 30 of them as I copy around. Anyway, so
this happens in banking systems where you're supposed to move money around from different accounts, but it's like critically important that you don't either create or destroy money.
Yes.
And so you have to be very, very careful.
So I wrote a freaking banking system in order to track the cubes, which I could get out of the box. But you have these like cards.
Uh-huh.
My camera.
That's the gem collector and the master burglar. And
these are like relatively advanced cards. But you like build a deck, and your deck gets kind of like better as you go. And there's very little deck removal. And some of the things you make noise, and like as you make noise, the cubes represent like noise. You toss them into an area, and then when the dragon gets mad, they get sucked out of the area and thrown in a bag. And then you pull cubes out of the bag, and like if they pulled out your color, that represents damage, and that like gets put on your little damage meter.
Oh, because you're the one who made the noise.
Well, the more noise you make, the more chance you have that your noise cubes are drawn out of the noise.
That's a neat mechanic. That sounds neat. I like that.
Yeah. No, the game's fun. I played it a couple times. I know it way better. And it's interesting. The game, because all these games on the internet are on Board Game Geek. It's a big board game site, and there's discussions, and like the designer's there, and he's like, "Well, I really meant it this way," or like, "And the general philosophy of the game was this," and so I've tried to replicate that. We have a designer saying hello and asking for Godot. We unfortunately will not be doing Godot tonight, but maybe another night.
The Godot episode was very popular on YouTube, by the way. So,
we should do good advice.
Oh, we'll definitely go back to Godot, but not today.
Not today. We're doing another code tour tonight because I've been writing lots of dark code. So, shall we to the code?
To the code machine. Let's take a look.
Code machine. Bum, 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 bum. Why does it think? Oh, I see. I just changed the layout. The code machine was already there. Okay, so here we are. This is our little Dart project. I can show you what it does. Where's our terminal? Whoa, did they change how this works? So if we do Dart bin simulate. So I don't know if I can make this big. Oh, yeah. So this made a like 2-person game. It looks like I have very little logging.
Right.
It's just power. It's PowerShell doing PowerShell things. And like you can see the red player like bought a card, got a different card. You can also fight some of the cards. So like there you start with 10 cards, and then there's like row of cards. And there's a row of 6 cards, and some of them have like cards you can fight, like this thing, which is this like the like red cards. Some of them are like cards that you can like use right away, like this device. And some of them are just like cards like we talked about before. This is like gem collector who you can like add, and you like pay a cost down here for one of them. Or like you pay a different cost, the swords cost for the.
Is it difficult to see? Can you make your video larger so that we can see?
Oh, I can do that using the power of the video. I can just make it me. Whoa.
Whoa. How's that? Yes. Okay, that's much easier to see. Thank you.
Yeah. So like this is one of the monsters, and you pay swords basically to fight monsters, and you don't get them in your deck, obviously, but these you do add to your deck, and you pay skill to get them. Anyways, this game you can buy it on Amazon or wherever your local game shop is. You were saying, sorry?
No, I understood what you were saying.
Yeah, so you can see that they're acquiring it, and basically you have these three kinds of resources. I think you have skill, you have four kinds: skill, swords, which we talked about both, and then you have boots, and it requires one boot to do any amount of movement. But then some things on the board, if we go back to the board again, I mean, this is different than before because you've like never seen the game. So like you can see some of those paths have grumpy monsters, and those you need swords in order to pass. You can also take damage to pass them instead, but that's
I see some of them. One of them has a footprint. Does that take a boot to get past?
It takes an extra boot.
Oh,
so every tunnel takes a boot, but that's an extra boot.
Okay.
And so then you can see.
I'm detecting a lot of graphs. Like I'm imagining your code is like full of graph theory somehow.
Well, let's go look at the graph theory part of the code in the place called. Hold on. The place called. Really? Where did it go? A place called graph.
Oh, graph. Okay. How
so
sensible.
I learned from Cauldron Quest that like I wanted to. Cauldron Quest I started with a bunch of arrays, and then I moved to like a graph that you could actually walk around and stuff. And this I started with this also because the edges, unlike in Cauldron Quest where the edges don't matter, like the edges matter here because you can have an extra boots cost, a swords cost. Some of the edges require a key that you have to buy. Some of the edges, the only way to cross them because they're one way is using a teleporter.
Oh, interesting.
And then there's very one edge. Like the only way to get back out is if you also have an artifact. Otherwise, you're stuck in the dungeon. You have to go down, get an artifact. Then once you get an artifact, the dragon gets madder, and then you have to race back out.
Mm-hmm.
So the edges matter. Tokens. This is basically directly stolen from Cauldron Quest. It has move to and remove from board. There's different kinds of tokens. We can worry about that later. And then spaces, right? So the blue ones where you like, they're cold. And so you like, if you enter a blue one, you like lose the ability to spend boots, which is your movement ability for the rest of the turn.
Because your feet froze or your boots froze? Oh,
okay. And then there's like there's a card. I might even have it near. Yeah, here. Which lets you like go around that idea. I actually recently added this one. So it gives you 2 boots, right, to spend. It gives you 2 Clank, which that's the name of the game, right? But that's the like noise that you're making to wake up the dragon. Uh-huh. And then you don't have to stop in the cold.
Okay, so they're like, I would have called this like boot warmers or something, but.
Well, they have some quip at the bottom, but like why they call it that, right? As the idea of dead run. I didn't type in any flavor text, into my simulation. I stuck just to the numbers, but there's flavor text in the game. Anyway, so this was all building up towards I have a graph builder. If you remember from the Cauldron Quest episode, I had this little connect function for connecting to things. It's slightly more complicated here. And then I have my front graph builder because this is a clever thing they did in this game, is that they have a 2-sided board.
Oh.
It gives you more replayability. I haven't done the back side of the board, but the front and back side of the board are totally different. And so the connected graph is totally different. I
see. So this is just basically hard coding the front of the board.
This is all hard coding, right? So I actually didn't type it all in because it's quite a bit. This is only enough of the board. This was one of the first things I had to write in order to do any of this, right? So I wrote
the board for the board game. Makes sense.
To get to like an MVP stage where I could get to a single artifact and like get in and get out. And so I typed in enough of the board, which included going down 4 rows of boards. So it's like 20 squares or something like that. And so you can see I make the starting square, I build the first row, I connect the start to the first of the first row, I build the second row, I build some connections in between those two. And if you look at any one of these, like the first row, it just allocates a bunch of spaces and gives them these numeric names, but I don't do anything with those. And then some of them can contain secrets, basically, which when you walk into a space, you like get the token on it. There's way more rules in this thing than Cauldron Quest. It's actually, I'm not like a super game connoisseur, but I was very impressed with the authors of this game of how well they explain it in 8 pages or whatever it is. Maybe it's 10 pages. They pack a lot of rules into a small space that you actually can like read, and it's reasonable to read.
Sometimes I find with these games that the clarity is, if you try to write the code for the rules, you realize that they're sort of more ambiguous than they seem at first when you read them.
I think that's actually a feature of board games. I think like one of the part of the appeal of board games is that you can have house rules, and that it's okay if you screw them up a little bit. I think that makes them harder to like translate into games. Like I have a README where I've written down some of the like edge case questions. I actually have a local patch on another machine where I have some more edge case questions.
Well, maybe on Board Game Geek you could get the designer to answer your edge case questions.
Well, this game came out in like 2015 or something like that, so the designer's probably 8 games later. But potentially, I think when I get this done, I will, it's already obviously public on the internet, but like I will send it out to Board Game Geek and ask people like, how did they resolve these 5 edge cases that I found? So,
yeah, my game culture mostly comes from like classic card games like poker and bridge, and then Magic the Gathering, all of which have very precise and well settled rules. And I was learning that the Warhammer community is actually quite different, where the rules are much less well settled, and so there's a lot of room for interpretation in that community. I just find it sort of a different sort of cultural way to engage in a game. Well, like I guess I did play Monopoly as a kid, which we had a bunch of custom rules. Which actually a lot of ours were just sort of at the time when we bought the game came with a bunch of suggested house rules. I think we just like adopted them all because they seemed like a good idea. But apparently the modern Monopoly game, it's like really insistent that some of the house rules that I played with as a kid are not legit, even though I'm pretty sure they were suggested to me by the box.
I actually think it's very interesting to think about, like, so when you're designing something for a computer, I think you tend to make things regular, because like you already have the ability to do X. Well, let's just do everything through X. Whereas I don't think you do that when you just have tokens on a board. And I think you can kind of notice that in your trying to translate it, because a lot of the game is very regular. Like I would say I would get 60% of the cards or more by just having, I could go back to by just having like the ability to add boots or the ability to add, gold or whatever like that. But then they also clearly designed this with tokens and a board, because then they do crazy things. And you're like, well, how am I going to do that on a computer?
Can you show us an example of a crazy one that?
Well, like one that I'm trying to work on right now is they have this concept of trashing. So trashing means you get to like throw away a card, but it's a timing question. So the rules explicitly state that trashing happens at the end of the turn. But when do you pick? Because like if you choose something to trash, so when you trash, you can only choose from played cards, so your play area, or your discard pile. You can't trash something out of your hand. Like if you have something in your hand, you have to play it. That's part of the game, is you just always have to play all of your cards. They also have this philosophy in the design of the game that you should just be able to play all your cards at the beginning and then like resolve all the stuff later. Because I think a lot of people play that way. They're just like, oh, here's my hand, and now I'm going to do this, and I'm going to do that, and I'm going to do that. I like that philosophy, but it makes for these sort of weird timing questions, because some of the things do have timing elements. Like there's a card that can make the dragon attack in the middle of the board. But there's also cards that give you Clank, so put cubes in the thing. There's also cards that give you negative Clank. And negative Clank has explicit rules where like it carries over. So like if you go negative on your turn and then you play positive later, as long as it's still on your turn, it like zeroes itself out, but you lose the negative Clank at the end of the turn.
Oh, whoa, that's neat.
So I can like show you that function. It's quite long to make sure I do the accounting right.
Yeah, I'd love to see it. That sounds interesting.
Let's see. I tell you, we need like a video producer here. Let's see. So to that one, I haven't sorted where all this stuff goes yet, but in the turn function, I have to do this adjust Clank stuff, because I have to handle the case of you having leftover negativeness, as well as, you may be adding negative or positive. I suspect if I thought long and hard, or maybe talked it out with you, I could actually make this function a little bit shorter, but this is where I got to. I can walk you through it if you like.
Well, I feel like maybe we should keep doing more context because I'm not sure. So yeah. I understood the graph file. Do you want to walk us through this? Is this the next file to walk through? Or?
No, I think the next file to walk through is the one with all the crazy Dart, which is the cards. So this class just makes it possible to declare cards. You, again, have worked with me enough. I really like writing sort of like DSLs to... I don't know.
So you just explain what DSLs are to the
sorry, a domain-specific language, which is basically where you take a language and you make a bunch of templates, or you make a bunch of like stuff to like make your specific usage of that language easier. And I mean, you and I have done this all
an example is like in Flutter, the widget system is that, right? We abused some syntax in Dart to build this hierarchical tree of things that are widgets.
Yep. I mean, the widgets example is sort of an extreme example because it became so popular that it has like changed the language in some ways, right? The like so much of the constness of Dart in the last years is to like make more widgets const, right? Or the trailing comma at the end. Like I even use it right here. Like if you remove this trailing comma in Dart, it changes the layout. That's not actually a great example of that, but the Dart formatter like used to try and compress to like fewest lines. Flutter style is much more written this way. Anyway, so I wrote up this, again, this is all pretext that you don't really need, just so I could do this giant array of cards. Right, so here are the starter cards. Very simple. It's in the starter set, which you could even get away from this, and I did in a different area. It's a starter set. This is its name. There's 24 of them, but you could argue whether this really belongs here. And all it does is give you one skill when you play it.
So you always start the game with the same deck.
Yeah, everybody starts with the same 10 cards, which it's like 6 of them. Actually, Burgle, I'm not actually sure this is right. Oh, maybe it is. No. Yeah, you start with 6 Burgles, 1 Scramble, 1 Sidestep, and 2 Stumbles.
I see.
The game plays up to 4 players. So everybody starts with the same, and then you start to... This is very similar to... not Innovation. There's another deck building game.
Talk about Dominion?
Dominion, yes. Dominion has a somewhat similar feel. This is like Dominion, but you like go on an adventure like across the board. Like if Dominion had a board, that's kind of what this game feels like.
Yeah, Dominion is a much more pure like deck building resource accounting game.
Yeah. And this game has less of the like go infinite kind of stuff that Dominion does. Dominion, some of it is like, but it has the same kind of feel of, well, you have 2 competing strategies of you can go really deep and get the really amazing artifact that's worth a bajillion points, or you can just go and grab the first artifact, make the dragon mad, and then race out while everybody dies. In fact, one of the things
that sounds like a lot of fun, actually.
One of the things that I think they did really well is that when the first person exits, there are now 4 more turns of the game. And they don't just say it like that. They're like, oh, you put your pawn as the first person exit on this little countdown timer, and then every time it's your turn, like the dragon gets more mad and does more damage to everyone.
Until at the end, the dragon is just mowing everybody down on turn.
Well, exactly. Like if you get to the end, it's just everyone gets knocked out immediately and the game ends. They just did a really nice job. I think the game is well designed. Now that I've stared at it for some many hours. But like here's another example. This one's in the reserve, which again. I could show you a different area where I made a slightly fancier DSL. This was my first DSL that I wrote for this game. Mercenary, there's 15 of these. So these don't get distributed. These just get put in a deck. Sorry, the reserve is the like always available. This also happens in Dominion, right? Dominion, there's like always available cards that you can always buy.
You can always add to your deck.
What'd you say?
Yeah.
That's the same thing here. Is the reserve. There's 3 normal cards, and there's 1 thing that you can always fight, and basically the fight thing allows you to trade 2 swords and make 1 skill out of it. or 1 gold out of it. I can't remember which. So these are always possible to buy, and has the same feel as Dominion, where there's like a card where you can turn points into score. You can turn skill, like the resource, into score. And then there's just a bunch of stuff, like there's 60 cards, no, there's more than 60 cards, there's like 100 and something cards that are in the dungeon deck, which like you'll see some of them in that game, maybe not all of them. So, and again, they do all sorts of different things. Some of them are different types. They give you points. Some of them make you draw cards.
So does your sort of card-based type understand all possible cards that could be made? Like
my card type almost does. One of the things that I've had to do recently is that there's these like enums where I have to do things like this.
Oh, I see.
Like you're going to do some special behavior because what you're trying to do is harder than what like normal people can do.
Yes, what I learned about the so there's a they made an online version of Magic the Gathering, which also has many cards with many different effects. And I was curious for a long time, like how they program each of the cards.
Mm-hmm.
And what I learned is they actually wrote a parser for the rules text on the cards. So the way they program the cards, they literally just type in the official rules text, and they have an engine that understands the grammar and can extract out from that what the behavior of the card is.
So that's fascinating. It doesn't surprise me that much that they would do it that way, because it's actually really efficient in the sense of it like lets them have a single pipeline. Like you speak both to humans and to the machine. But what that system will do is it will cause your cards to get more regular, because your designers will now have disincentives, immediate disincentives, because they'll try and feed them into the machine so they can play them, in their online playtesting or whatever, and it won't work.
So I think they defeat this by not doing online playtesting. They playtest on little scraps of paper, and then the rules managers have to come in and tell them that they've designed a card that cannot exist in the rules, and then they like duke it out in some conference room or something, and that's what happens.
Yeah, but I think it's like one of the frustrations that we have in like software design is this designer developer gap. There's a lot of talk about this right now with Figma and all that, like, and redlining is where you like design out your screen and then you like draw the red lines for this should be 5 pixels from here or whatever. And there's that air gap. But what I'm saying is I actually think in this, I think the air gap is useful. And I've learned, particularly from typing in this one, that there are times when the air gap is good. Like I'm glad
it frees the designers to have more creative designs. Yeah.
Yeah, to just think how they ever should, as opposed to like, will it work?
You have trouble. Like I'm a terrible like tester of software, because I have a mental model of how the software works, and there's like invisible walls that I never want to cross, which are exactly the walls that if you cross, the software will break.
Huh.
And they're like people who are like the opposite of this, who are just like gifted software testers.
Sure.
Who will like you give them anything and they'll just like immediately break it because they have the opposite intuition.
5-year-olds. But yes.
Yeah. So 5-year-olds are good because they have a very different mental model of the world, and so things that they think are totally sensible things you think of as absurd, and the people who wrote the computer also think are absurd, and therefore confuses the computer to no end.
Yeah. No, it's been interesting. Also, I think I spoke about this on a previous episode, to just continue to open my eyes about how biased so much of software is right now, biased towards one learning model. In particular, and maybe others in the comments will dispute that. But again, watching my wife engage with this, watching others engage with our product Flutter at work, I just realized there are lots of people who like look at the world differently than I do, and we have certainly tried on our project to do a good job about that, but there's so much better to do.
Yeah, there's so much work that we put into product inclusion. It's a really hard problem because the like diversity of human beings in the world is just astronomical, and like finding a way to include everyone is just like requires a lot of like diligent work to understand like what different people's needs are, how to meet them, how to address them, where you're falling short. It's a very, very difficult problem.
Yep, we can do better, and we will do better. But is there more you want to see? I don't know.
There were some cards you hadn't done yet. I was sort of curious what they were, and maybe we could try to ride along while you You try to do one of them or something.
There's probably other things that are maybe simpler to do. Like we could program the market or something like that. Like that's something I haven't done. That actually is probably, I'm trying to think what would be interesting for stream. The difficulty, like the cards, like a card that I'm working on right now. Let's see, how do I make myself be? Well, I'm working on this card right now.
Wand of Wind. Okay.
Teleport to an adjacent room or take a secret from an adjacent room. And like, it's not a straightforward card to program, for one. And then the second thing is, part of what's difficult wrapping my head around it is the timing of it. Is like the take a secret from a different room. So normally what happens, if I pull up, I'll tell you, where's our videographer here? So our planner, I actually think this worked out well. Like I learned a bunch from, so I've separated the idea of planning, which right now the planner that we have is a random planner.
You just pick a random action. Okay, that's a good place to start.
Literally, it does. This used to be part of the planner, but I split it out. This was actually a good thing. This felt like a good design decision. Is that I have an action generator, and its job is to tell you all the possible things that it can be done right now.
Mm-hmm.
And then the random planner doesn't try to rank them or anything like that. It just
picks one and says, "Do that one."
Shuffles them and do that. It has one caveat, which is that it will try and play all the cards first. That's just sort of how the game is thought through. That like all the cards should get played first.
So this sounds like a card that's going to generate an action, or generate a choice of some sort.
Yeah. So there's this difficulty between what things are immediate and what things are not, and the designers tried to be very friendly, as I said earlier, of you just like splatting out all of your cards. So like this is a good example. This card both has resources on it, as well as does something unique. It replaces a card on the dungeon deck, or on the dungeon row, right? And so the designers, I think pretty clearly from Board Game Geek, want it to be possible for you to just splat this down at the beginning of your turn, and then separately decide when to do the like later half of the action.
So you get the resources right away, and then you get an option to later, or maybe you're required to eventually do the generating action.
Yes, for things that get split like that, you're required to do the latter half. You just are allowed.
You can choose to do it later.
Yeah. And they don't really say that explicitly, but it's very clear in their answers on Board Game Geek, and just like, but that's the sentiment. They were trying to make the game really friendly to play, just like blah. But that makes it really difficult to program, particularly when there are things like, if we go back to Wand of Wind, where it's like, so the teleport thing, there are other things where, notice Wand of Wind does not have any resources.
Okay.
So you wouldn't ever play it at the front of your turn being like, oh, we'll just, let me hold on to my teleport token. Let me hold on to my take secret token.
Mm-hmm.
You would sort of expect those to happen at the same time. And so currently I have teleports actually implemented in the delayed functionality, because other things that do teleport you have this property where they want to, like, you want to get their resources, but then later teleport. And so the question is with Wand of Wind is like, when you choose the action, do you need to include the where you're teleporting to, or do you just get like a teleport token? And then again, because it's an or card where you're choosing one or the other, which was another thing that I recently added and it's complicated. Do you, for the second one where you're taking a secret, is it the same thing? Do you get like a take a secret token that you like later spend during your turn?
I mean, naively from what you showed so far, I would imagine that you would get an action, which is make a choice. And then when you took that action, you would then have to pick either the top half or the bottom half of the card, which would then generate an action that would go back into your set of possible actions to take. And then you could later take that action if you wanted to.
And this is why
that's accurate, but
this is why I should have talked to you before I wrote it all out. I wrote out a more complicated system where, and this commit actually hasn't landed yet because I haven't finished it. I have other things that I do in my life besides code up board games. But
I don't believe it, Eric.
I hard coded, or yeah, I didn't quite do it that way. I think in part because anyways, I've probably gotten like myself wrapped up in knots about this, and this is part of one of the things I've learned actually from this show, doing the show with you, is that I'm a very flow-based programmer. I didn't know this about myself until I did this, but I really need to just like get into the zone and go for a while. And so that's the kind of thing that I would just like noodle on for a while. Anyways,
I had very similar experiences where I work on a problem for a long time and I'll be stuck on some aspect of it, and I just can't like see the solution to it. And then I'll just like leave it as a to-do or file a bug about it, or like it'll be really bothering me. I just like can't believe that there's a solution to it. And then somebody else on the project will just come by and be like, "Oh, this looks like a fun bug," and then like they write this like 3-line patch or whatever that fixes it, and then like move on with their life. And I'll stare at this 3-line patch and be like, how did we get to this? This is great. This is exactly the right thing.
Well, and this is why the show is named what it is. The idea of rubber duck engineering. Like, so I think we talked about this at the very, very first show, but this idea of rubber duck debugging, where you just explain your problem to a literal rubber duck sometimes, and that just that action of talking to someone and talking it through can really help. But anyways, there's a bunch of, I can actually show you, because this is written. Oh, hold on. I have to hit the right buttons. No, not that one. Not that button. But if you go to this and you go to box contents, we'll show you that I have implemented 61 separate card types. I actually don't. I haven't counted up the card types unique. And I'm able to generate 167 of 183 cards.
Well, that's neat. So it's giving you like a completion counter.
Basically. Oh, I want to show you one other like little thing that I thought was kind of cool. I learned, I've typed a lot of code. Where is loot? Loot. Poorly named loot. Here, this is another example of a DSL. But this one, I used name constructors.
Mm-hmm.
And this actually was really nice. Because instead of having like an enum for like, oh, this is a major secret type, like it does under the covers, but the name constructor handles all that for me. And the other nice thing about using a name constructor here is that it can restrict your choices. Because one of the other downsides of the like, here's your 85 parameter card type, is that in every single card, you have the ability to type one of the 85 parameters, some of which makes no sense. Like monsters are not ever allowed to have a skill cost. But by doing it this way,
you constrain some of the invariants so that you just can't type mistakes.
Exactly. And I find that so much of software is like making it impossible to type mistakes.
Mm-hmm.
I sent this to you over chat, sort of this week. Another thing I learned from this project was sort of a testing philosophy. Like I found myself at the very, very beginning just not writing very many tests, but now it's sort of snowballed as I write the like more and more, like this test file needs to get broken up because it's like 1,000 lines long. But I think this is like my very first test. I probably should go back and like make it nicer. Oh, that's not even the test. This is the test. Deck shuffles when empty.
That sounds like a good corner case of like what happens with empty decks.
And like the initial deal. But now I'm doing like, okay, that master key unlocks tunnels. And I've written crazier tests again that I haven't checked in, where I like test each corner case and I like make my own graph. And
oh wow.
There's just like there's a period where I think you said back to me that where the software is still hot,
mm-hmm.
and it just needs to like take some time to cool before you can like build around it. And I very much felt that this way.
Yeah, I feel like in the hot stage, the code is very malleable, and so you're often realizing that you made serious mistakes in the structure or the interface,
mm-hmm.
and so you're just breaking it all the time. But at some point, you're like, okay, I got the structure right. Like now, let's start like adding some like cooling it down, adding some mass to the system, making it harder to perturb, so then it converges eventually to something that you're trying to create.
I've also been, it's remarkable to me, I've been using Visual Studio Code to write all this, and Visual Studio Code is not like a super deep IDE. Like there are much deeper IDEs than this, but I've never been a big IDE guy. Like I use BBEdit and Sublime and things like that along the way. But refactoring tools, just like baseline refactoring tools, are just so much better than they were 15 years ago. That it is so cheap to sort of edit, like to reshape in somewhat large ways the system as it's still cooling.
Especially that it like takes your tests along with it. That's a huge win. Like,
yeah. Anyways, I found myself for parts of this also doing somewhat sort of test-driven development. I was asked about test-driven development on a podcast not too long ago, and I like tests a lot, but I was realizing through this as I was sort of introspecting that they're just one more tool in your toolbox.
Well, I feel like the test-driven development. So just to state the thesis of that, as I understand it, is that you're not supposed to ever write code in your main system. You're supposed to start out by writing your test, seeing that your test failed, and then make the minimal change to your system that makes your test pass. And then you do that for a while, and then you're allowed to make pure refactors to your system that do not change any behavior, but improve its internal structure without changing your test. And then you're supposed to continue in this way until you're done. Is that what you understand? That's what I understand test-driven development to mean.
It's totally what I'm doing right now. Like that is the phase of the system that I'm at. Like I will pick up the card and I will write the test as I wish to observe it in the system, because in some ways that's easier to do. Like when the dragon attacks, I can like test, oh, how many cubes got moved around without like having to go in and make the dragon attack inside the system. So yes, but I learned from this that there's a part of the test-driven development that interfaces with this like system cooling effect. And I don't think test-driven development works until the system is below a certain temperature threshold.
So can you elaborate on that? Like that makes sense intuitively, but I'm curious what how does that manifest, or how did you experience that?
Well, I experienced it again, just sort of in like as this test file evolves, because I didn't even know how to test. Like I didn't know how I was going to store negative Clank, or like the tests get more, but like by the time you get down here, I know how to take Master Key's not even a good example, like Master Burglar, right? This is a card. And I think I literally took this, like this boilerplate's silly and I need to fix that. But I just took the card and been like, okay, what happens when you do the card? Well, it gives you skill. It adds this little helper that I wrote adds the card to your deck in order to play it. And then I discard my hand because end of turn requires you to use all your cards. But then I run the end of turn function, which is when trashes happen, and it should happen. So like I think I wrote all this before I ever wrote any lines of code for the Master Burglar, because I could like understand the system and how you could observe it. But until the system had like cooled far enough that I had enough pieces and I knew enough about how the system, reasonably could come to be, I couldn't have written this.
That's like a discovery aspect where you're like trying to, at least the way I work, and I think it's similar for you, is you're trying to understand the conceptual model of the system. And there's like a waterfall theory of software development where you think a lot up front and you write a lot of documents or something where you figure out the conceptual model. But I've never found that terribly effective. I've always found it much more effective to go in there and try to start building it, and then have the code or the system structure tell me what the conceptual model should be. And then once you have the conceptual model, then you have the testing model somehow like comes along with that, because what you're doing is the test you just wrote is basically just saying that the concepts are working in the way that you expect.
There's also this other thing that I find myself doing as I build up systems like this, is that I'm constantly trying to like relax down to like a lower energy state where I'm doing less work. Because if I'm doing a lot of work in the system, then I've clearly not designed the underpinnings right. And so
I think that like one thing you haven't done in this project that you've done in previous projects and we've done previously on the show is to tech up to a string-based representation of things. Like you still have very imperative, like even your board construction, right? Your board construction is very like connect up this and like test how many things in my hand and blah, blah, blah. Whereas in other things we said, okay, let me make a little concise notation for what the world is like. Then let me run my steps on it. And then let me check that the world is this golden string. And it becomes very terse and get a lot of conceptual leverage out of very few keystrokes.
Yeah, I've also heard those referred to as fixtures, or like fixture-based testing, where you like basically you freeze dry your system and you like thaw it out and then like play with it. Those tend to be very brittle. I think those, like I feel like someone could write the big Medium post about like the glacial cooling of software or whatever. Or the annealing or whatever. What is it where you like you rapidly heat and cool steel and then it like changes somehow?
Oh, tempering, I think.
Tempering, yes. Like we're tempering the software, but the
it's really hard to heat the software back up. Like once the software cools, it takes a lot of work to bend the sword into a scythe.
It does. Anyway, I think that's such a brittle way of testing because you don't understand your fixtures. The fixtures are often not editable. Like when you serialize out your board into a board string, it's not like you can look at that board string and be like, But you know, the flip side is that this imperative thing, you're just copy pasting. Like I could probably, if I had a fixture based system, I could write this whole 1,000-line test in half the lines possibly. But
yeah, we encountered this in Flutter when we built the widget tester object, because before that we were very manually constructing things, and we found that we kept doing the same thing over and over again. So I think Ian Hickson designed the system that made the widget tester like it was like your friend, and you would like tell it a story. If you like make my widget tree like this, and then like make some time pass, and like it was this very like storytelling based way of doing it. And then you could like ask the widget tester, hey, widget tester, can you find anything in my tree with these kind of properties? And it'd be like, yes, I found exactly one of them. And you're like, cool, we did it right.
I like that.
And then the neat thing was once we had that, he then built multiple backends for it so that it could test basically in an isolated environment. It could test like on a device, on a real device. And it could also test in a graphical way, so you could actually step through and see exactly what your tree looked like. And it was fascinating to go back to some of the earlier tests that we had written that were purely designed in this text-only editor thing, and then go look at them, like what do they actually look like when you rendered them? And they look like totally like not what you would expect them to look like. Or like I never like constructed a visual impression of what my test was going to draw. Because like there was the opposite of, so when we used to work on WebKit, we had these things called layout tests where we're similar, but you basically write a little mini web page, and then you could either dump out the state of the web page either as text or as like a textual tree.
Well, initially you couldn't do text. I don't know if you were around that.
No, that predates me. I know that, and you could also do it as like a PNG of like exactly what the
layout tests used to only be PNGs. And then Hyatt or somebody added, was probably Hyatt, this was a long time ago. Dave Hyatt used to work on Safari, used to have a blog. But anyways, I think he added like render tree dumps. But then like render tree dumps were also fragile. And so then like Darren Adler or somebody added like text-based dumps. And anyways, I ruined your story, but.
Well, the story I just could tell is because the web pages are so visually oriented, you would design them in a visual way. So you'd often use like green as like a good color and red as a bad color, even though you were eventually going to just dump as text and look at the text. Like you would still like use those conventions. And like in the early Flutter tests were totally not like that. Basically, all of the Flutter tests were completely invisible, transparent black was like all it ever was. And so you would look at them and you're like, I can't see anything. But later on, once we had the visual ability, like more complicated tests, we would design them like looking at them because they were too hard to just do in your head. You had to actually see them to figure out what you were testing. And so those, when you actually look at them, have some like visual meaning to them, and you could actually debug them and understand them in a visual way.
As you were saying this, I realized I think there's more to this our tempering theory of software. I think that there's also when you like add, I don't know if this is true, but I'm going to pretend it's true. Someone in the comics who actually knows physics. I think when you like cool one metal and then you like add another hot metal on top of it, it doesn't like bond with the cold metal. And I think that's true in software too. And so you end up with layers, but you have to like have ways for these like metals to interact. And so you have to have like ways for your layers to interlock. Maybe APIs. And I think that you end up with this like, I really like my analogy here, or this analogy here. You end up needing these layers. And I think this is, again, one of the things that I think Ian and you and others did really well in Flutter is having all these shearing layers. But when you have all these layers, you can imagine yanking one out, pouring in some new hot metal, and cooling it in a shape that fits into the.
I mean, this is the dream of test-driven development, right? Like once you have all these tests, you could like totally rip out the inside of your system and plop in a whole new game engine that does things in a different way, and the test would then tell you whether you've done it correctly, or at least catch you in mistakes or subtle errors in that process.
Yeah.
But it ends up being hard, right? Because you have your whatever it is multi-thousand line test file, and like it just takes a lot of typing to build a new game engine that is sufficiently like complete to pass all those tests. And
when it helps, this is now my 4th or 5th or I don't know 10th or something of these. If I press the buttons again here, because there's hold on. I think I did a better job of designing this time because I split the planner out. This turn shouldn't be in here, but like as you saw earlier, I split this like action generator out. There's this also question about like what's trusted and what's untrusted, and the planner is untrusted. Go ahead.
Yeah, when we talked about the Cauldron Crest game, one thing we talked about was doing some sort of like AI planning.
Yep.
But it seems like the structure you have here is much more amenable to that because you've resolved down the intelligence question to a sort of finite choice question as opposed to like a deep understanding of dice and pips and things like that.
Well, that's kind of where I'm going. I'm also, one of the other things I'm doing in my copious, clearly not, but free time is watching ML videos because it's like an area of computer science that I just don't know much about. And so, yeah, I think it would be interesting if I can get all the like imperative rules somewhere. You could imagine having analysis of the board states and turning them into something that, whether it's ML or whatever, but something else can understand. You could imagine, driving simulations on top of this. I don't actually know that this is a particularly interesting game to like build an AI for, but one aspect that I do think is interesting about this game is that it's designed, and I think other games are designed this way too, to have multiple high points in the strategy space. One of the things I think you can learn from simulations like this is that you can compare. So does like rock, paper, scissors, right? Rock, paper, scissors is like that's not a continuous graph on rock, paper, scissors of the strategy space, right? You're either rock or you're scissors, but there's a little bit of, do we lose each other? Okay, there. There's a little bit of that here in that you can play the, okay, go deep and grab the really expensive artifact strategy against the, okay, go shallow and grab the little artifact, right? As an example.
And so is there like a meta level strategy of like saying, given the situation that I'm in, which of those two sort of attractors should I go for?
Yeah. I mean, that's why many, many years ago, I wrote a simulator for parts of League of Legends, which I played some many years ago. Many, many, many years ago, you and I worked on some simulators for Bridge. And, it's just all asking that same question, like, what is the meta? Like, what is the strategy?
Yeah, the dream that we never really got to with Bridge, and I haven't really got to any of these projects, is to have all this code tell me something that I didn't know before. Like, tell me something interesting about the strategy space that wasn't obvious to me. And with Bridge, there was a little bit of that because we built all these complicated rules for the bidding system. And so I learned a lot more about why the experts had designed the systems that way, which was interesting. But I didn't learn anything like you described these two strategy attractors in Clank. Like maybe there's a third one that you're not aware of. And wouldn't it be neat if somehow in this process you could come to learn that?
Yeah, I mean, that's the whole ballgame for me. It's like I felt like I learned some of that from Cauldron Quest. Obviously, it's like there's not a lot of strategy to Cauldron Quest. No offense.
You learn about that, like sensitivity, like which of your choices had a big or small outcome on the result.
And I think too often I've sort of gotten to the 90% or the 80%, and I've not actually gone that last interesting 5% in these projects because, whatever, I get distracted or busy at work or whatnot. But I think I'm some percentage away from being able to start to ask those questions. I don't know that I know how to answer them, but I think it would be interesting. Like, how many high points are there in the strategy space?
Yeah, so one possibility, maybe we could do this for a future episode, is we could design a much, much simpler game and focus on the planning aspect of that game. And then, like, you clearly have become very facile with building very, very complex game engines. And so if we tech up the tree of building more interesting or dynamic or automatic planners, we could apply them to more and more complex game engines and perhaps eventually arrive at a game like Clank.
I think that would be absolutely fascinating and a fun thing to explore on the. And I would definitely want to try something, like checkers level. Not checkers, because I don't think checkers has the same sort of continuous strategy space with these these dips, but there must be a game. So
yeah, we should probably research it and figure out what that game. It could be a very, very simple game, like a game where you only have a few choices anytime or something.
There's probably PhD papers on this that we just need to go read.
Like I bet if we went to the library and got a book on like machine learning, they would have some examples that would be the right ones. But is that our learning style, or do we have a different learning style?
We may have a different learning style. I certainly have a different learning style. Going to the library and reading books. It's funny, when I was first learning computer science. So I went to a college that didn't have a computer science. It had a computer science department, sort of. It was like a professor and a half, and it sort of had a computer science major, but it wasn't really its thing. And so I spent so much of my time in college just renting books from the Berkeley library, like University of Berkeley, via the interlibrary loan system, which is amazing, by the way. And if you're a college student watching this, you should use your interlibrary loan system. Maybe it's all supplanted by the internet, but it was amazing. But I learned a lot from books then. But that was pre-Google too. So now I didn't.
I've learned from books, but I don't learn from books that well. Like, I learn much better just by trying and doing.
Yeah.
Or I feel like I learn the lesson more deeply. Like, I can recite to you facts from a book, but I don't understand them in the same way that I understand other things.
Well, now I deeply understand the Clank rules. So if you ever need a Clank expert, I'm there for you.
To get your Clank judge pin or something.
But something like that. So do you have any last minute thoughts for all our intrepid viewers this evening?
I think this planning problem is interesting. I think it may be worth digging into, and we'll have to think about what a good format is to do it on the show. But I'm interested in it.
We also touched on this somewhat, like the ecosystem. Like, I'm still fascinated by genetic algorithms. Like, I don't even know if that's the right term. I've never successfully built anything in that mode. Like, that's what I would want to do with something like this. It's like unsupervised learning, I think, is one of the terms of art, again, which I know nothing about or next to nothing about. I think it would be fascinating to apply some sort of unsupervised learning kind of thing to this space and discover that there really are, 8 points of the strategy space, only 3 of which humans are using.
All right, should we make a commitment? Next episode, unsupervised learning of something?
Yeah. In the future. Let's let's not restrict ourselves. Anyways,
fair enough.
Wonderful to see you, Dr. Barth.
Good to see you, Eric. thank you for showing us the code. I found it very interesting, especially interesting to compare against the Cauldron Quest from a couple episodes ago.
Well, you see, I get better at things with practice, as I tell my 5-year-old all the time.
Practice makes perfect.
Any updates for the audience about our pizza successes? Did you have a pizza success this week? I didn't ask.
Pizza is scheduled for next week. We don't have pizza every week, Eric.
Oh, see, I cook bread every week. I haven't done my. I'm now in a habit though where my kid goes to a play date on the weekends, and it has now become known that I cook bread and that the kid should come with bread every play date.
That's his ticket into the play date.
It's yeah. Anyways, wonderful to see you. I'll see you in a week.
Yep, good to see you. See you next week.